Let's talk about the sum and difference identities for sine. So, just like for cosine, we have sum and difference identities for sine. With sine of alpha plus beta, it's a mixed match. We have sine of alpha times cosine of beta plus cosine of alpha times sine of beta. So there are various mnemonics that you can use to try to remember this, but the important thing is that you practice using it, and if you need to, you can look it up. And then similarly, we have a difference formula for sine, so sine of alpha minus beta is equal to sine of alpha cos of beta minus cos of alpha sine of beta. So again, with sine, the signs match. With cosine, the signs were opposites. So hopefully that may help you remember it a little bit. But anyway, let's see how we can use the sum and difference identities for sine to compute exact values for certain angles that we wouldn't know otherwise. So here's an example. Let's compute sine of 105 degrees. And 105 degrees is not a standard angle on our unit circle that we know off the top of our heads. But what we can notice is that, remember, our sine addition identity, or our sum identity, allows us, if we know the sine and cosine of alpha and the cosine of sine and cosine of beta, we can express sine of a sum of angles in terms of those sine and cosine values. So in this case, just notice that 105 degrees is the same as 60 degrees plus 45 degrees. So 60 and 45 are nice angles because we know what their sine and cosine values are. And so having expressed this as sine of a sum of angles that we know, we can now use our sum formula, our sum identity for sine, to write this as sine of the first angle. So sine of 60 degrees times cosine of the second angle. So cosine of 45 degrees. And then we have plus, now it's cosine of the first angle, so cosine of 60 degrees, times sine of the second angle, so sine of 45 degrees. And again, we know all of these values, so we can compute these. So what do we get? Well, sine of 60 degrees is the square root of 3 over 2. Cosine of 45 degrees is the square root of 2 over 2. The cosine of 60 degrees is a half. And the sine of 45 degrees is the square root of 2 over 2. And now we can just simplify this. We have the square root of 3 times the square root of 2, which is the square root of 6. And we're going to have a common denominator of 4. So it's just the square root of 6 plus the square root of 2 all over 4. So that is what sine of 105 degrees is. Now, let's do an example where we compute sine of an angle in radians, and this time we're going to have to give a little thought to figure out how we can express an angle in radians in terms of angles in radians that we know. So one way we could do this is just to say, well, what is pi over 12? Well, pi over 12 we can express in degrees by using our conversion factor, 180 degrees over pi radians. And when we simplify that, the pi's cancel. And we get 180 degrees divided by 12, and that turns out to be 15. So the pi's cancel, and 180 over 12 is 15. So this is 15 degrees. So that can help us. If you're ever unsure about doing something in radians, you can always convert it to degrees, which we're maybe a little bit more familiar with, and then do that. But so in this case, 15 degrees we can think of as a difference of angles that we know. In this case, 45 and 30, right? 15 degrees is the same as 45 degrees minus 30 degrees. And we know 45 degrees, we know 30 degrees, those are standard angles. We know all their sine and cosine values. And so we'll be able to use this and our sum and difference formula, in this case the difference formula, to express this in values that we know. So we think about, we just consult again our difference formula. It is sine of the first angle times cosine of the second angle minus cosine of the first angle times sine of the second angle. Okay, now again we know these values, we can just plug them in and simplify. So sine of 45 degrees is the square root of 2 over 2. Cosine of 30 degrees is the square root of 3 over 2. Minus cosine of 45 degrees is the square root of 2 over 2. And sine of 30 degrees is a half. And so getting a common denominator, which is 4, we get the square root of 6 minus the square root of 2 all over 4. So that is sine of 15 degrees. And we could have also done this in radians, right? We could have also said that, well, 15 degrees is 45 degrees minus 30 degrees, or equivalently, 45 degrees, which is pi over 4, minus 30 degrees, which is pi over 6. And you can check that pi over 4 minus pi over 6 really is pi over 12. And we could have carried out the same computation using our difference formula, and it would have come out the same. It's really a matter of preference. If you're more comfortable working in degrees, you can convert degrees and do it that way. If you're fine with radians, you can do it that way too.